Hello, welcome to this lesson of our study of systems of linear equations, and in this I'm going to solve the last problem I was solving, systems of linear equations, and probably move to a new topic in linear algebra. So I've been given this system, right? That given the system x plus y, that and those things. We know a and b are constants, and the system does not have a unique solution, but it is consistent, right? So we're supposed to determine the values of a and b. The first thing is I'm going to write augmented matrix from this system. I have 2 here, 1 2 1. I have another 2 here, 2 a 5, and I have another b here, right? So for this system to have no unique solution, then this matrix I get here, the matrix A, which is equal to 1 2 2 1 2 1 2 a 5, should have a determinant of 0. And in one of our videos I said that if you have a 3 by 3 matrix and you're trying to find a determinant, there's a quick way of doing that. 2 1 a, no, that is 2a5, right? This was a matrix I chose, so that's the coefficient of the variables. So if your system has no unique solution, then a matrix formed by the coefficient of the variables should have a determinant of 0. And I said to write a determinant I have to get these guys, which is coming from taking these values. So I start from 2, go to 1 1, and then end at 2 again, right? So that's what I have, 2 1 1, then end at 2. And then I go to the next row, the last row here. I'm going to start from a 5 to a, right? And now the determinant will be just writing these values. So I have 1 in front of this guy times that is 10 minus a, these two products, plus I have another 1 here, so I'm going to write 1 into this times that minus this. So I'm going to have 2 minus 5, and that is going to be negative 3. And then I'm going to have plus 2 into this times that, which is a minus 4, right? And that determinant should give me 0. Okay, so that is what it means to have a system with no unique solution. So I'm going to have 10 minus a minus 3 plus 2a minus 8 should be 0, right? And this, from this, I'm going to have 10 here, right, minus 3, and then minus 8. What would that give me? That's going to give me this minus 3 minus 8 is going to give me negative 11 plus 10, and that's going to be negative 1. Negative a here plus 2a, and that's going to give me a. So a should be equal to 1, and that is the solution, right? Okay, so a now is 1, so we are supposed to find a and b. I know that a is 1. To find b, I just have to put a back in place of this augmented matrix which I wrote, and that is 1 2 1 1. I'm going to write this matrix again, and in that case I'm going to include a. So 1 1 2 2 1 2 1 2 2 1, because a is 2, sorry, a is 1, b. And this system is consistent. I know it has no unique solution, so obviously I'm going to get a situation where it has infinitely many solutions. So to reduce this, I'm going to do our usual. I'm going to subtract row 1 and row 2 to make sure that that guy is 0. I'm going to multiply row 1 by 2 and subtract it from row 3, right? So row 1 minus row 2 should give us our new row 2, and then 2 row 1 minus row 3 should give us our new row 3. And that is going to give me this new matrix here, 1 1 2 2, 0 here, and then 1 minus 2 is negative 1, 2 minus 1 is 1, and then 2 minus 2 is 0, right? And I go to, I go to the other one, the other rows. I'm going to have 0 here, 2 times row 1 minus that, so I'm going to have 1 here, I'm going to have negative 1 here, 4 minus b, right? So Now I'm going to multiply. I want to make sure that this guy is positive. I'm going to go to the next row and look for the leading value, and that is this, but it is negative. I want to make sure that it's positive. So what I'm going to do is -1 times row 2, or maybe negative row 2, and that is going to transform and give us a new matrix: 2 2 0 1 -1 0 0 1 -1 and 4 minus b. So what I'm going to do is now to make sure that the value under this 1 is 0. That is this value. Compare the two of them. So what I can do to the two of them is I can subtract them, right? So I'm going to have our new row 3. Row 3 is to be equal to row 2 minus original row 3. And that this is going to transform into our final matrix: 1 1 2 2 0 1 -1 0, and then 0 here, so 1 minus 1 is 0. -1 minus -1, and that is 0, because -1 minus -1 is going to be -1 plus 1, that is 0. I'm going to have 0 minus 4 minus b, and that's going to be b minus 4 here. Right. So if I have b minus 4 there, then what I can say is that for this system to be consistent, it means I have x, y, z here. It means that 0x plus 0y plus 0z should give me b minus 4. For it to be consistent, everything I'll get here will be 0, so that it means that b minus 4 should also be 0. So therefore, it means that I'm going to have b to be equal to 4. And in that case, if b is 4, then the system has, or maybe the system is consistent and it has infinitely many solutions. Now the next task to do is to solve for the solution. So find a solution. So if b is 4, and I know I've reduced my matrix, I'm going to have something like 1 1 2 2, and I had 0 0 1 -1 0. I had 0 0 0, and then if you remember, last part was b minus 4, right? This was it. And then b is 4, so if I put it down, I'm going to get 0 as well. Alright, so now what it means is that from, I'm not going to do for the last row, from the second row, it means I have x, y, z here, right? So I'm going to have that y minus z is equal to 0, so y is equal to z. And then in the first row, I'm going to have x plus y plus 2z to equal to 2, and that means that x plus 2z, because y is z, is equal to 2, and that x will be equal to 2 minus 2z. So here, same thing, choose z to be any variable you want. You can pick a p, an m, or whatever you want to pick, but it's supposed to be a real number. For this level, let's say t is a real number, right? So my x, y, z, this system is going to be, x is what? 2 minus z, so I'm going to have 2 minus t, or 2 minus 2t, sorry. And y is z, so I'm going to have t, and z is still t. Right, z is still t, so I'm going to have that. And if you want to split this into numbers plus these variable here, I'm going to have 2 0 0 plus t into -2 1 1, and that becomes my solution to this system, right? So yeah, that's how you use to find whether a system has a unique solution. So if you have a system and you want to check whether it has a unique solution or not, what you're supposed to do is form a matrix here. The ideal situation is if you've done matrices, I'm going to write this as 1 1 2 1 2 1, and this is 2a 5, and then x y z should be equal to 2 2 b. This is the actual thing. So if you find the determinant of that matrix you have there and you have 0, then you have a system has no unique solution, doesn't have unique solution. But if you get a determinant which is not 0, then your system is having a unique solution. Alright, thank you, and see you in our next lesson.